Hello guys, in this video we will discuss what variables are and how to define them in Python and how to use them. We will also briefly discuss the memory model used by Python and we'll go over what dynamically typed language is. I've also done a very similar video in Java as well, so if you guys are interested in that, please do check it out, as Java is still a very popular language and is used heavily in industry. Alright, so let's dive straight into what variables are. Variables are a way of storing data in memory temporarily. Python has 4 primitive variable types: integer, float, string, and boolean. And these types basically help us define other objects or other data types. Okay, so let's see how to define a variable in Python. So over here, let's say I have a variable a, and with this I have assigned a value 1. So this 1 is of type integer. Let's define another variable, let's call it b, and let's make this a decimal. So this is called a floating point number. So this is a float type number. Let's do another variable. Let's make this a string. Maybe you can say subscribe to, cannot spell subscribe, to Mr. Programmer. Just an R there. Okay. And let's do one more. Let's make this a boolean. Okay. So boolean can be either false or it could be true. So boolean has 2 values, true or false. All right. So let's say we want to add up variable a and b and store that into a new variable. So how would we do that? Well, we can just define a new variable. So let's call it add. And here we can do a plus b. So over here, we're adding up the value of variable a, which is 1, and the variable b, which is 2.2. And we can print that out. So we can do print add. In Python, I don't need a semicolon. So let me just remove that. There you go, 3.2. And let's say maybe we could change this to 5.5 or 505, and this to maybe 202.5. There you go, 707.5. We can do the same thing with the string as well. So maybe let's say I have a new variable like, and I can say, and also like this video. And let's say maybe we want to combine like and C. So let's just make a new variable, call it join string. And we can say C plus like. So with the plus, we're saying, okay, combine the value of C, which is this, and this. All right, so basically join them together, concat them. And we can print this string out. You can run it. There you go, subscribe to Mr. Programmer and also like this video. So the next thing I want to go over a local variable. So local variable is something that's local to a function or a method. So in this case, A, B, C, all these variables are local to this function main. I cannot access these variables outside of this method main. So let's say if you had a new function called add, which basically sums up, 2 numbers, which takes in 2 parameters, A1 and B1, and adds them up. So let's say we store it in some res and we add A1 plus B1 and return the result. So some res is local to this function add. We cannot access this variable outside of this function. So for example, I cannot access that result here. So if I'm going to print some res, I will get a compile time error. All right, some res is not defined. I can only access it inside this function. So that's what a local variable is. Another type of variable is a global variable. So global variables are variables that can be accessed anywhere within the program, and these are generally defined outside of a function. So for example, let's say I have a global variable called channel. All right. That channel is Mr. Programmer. I can access this channel variable within this entire program. So I can access it here. So if I'm going to print out channel, I can access it there. I can also access it within the main method as well. It will print it out twice, Mr. Programmer. All right, so another type of variable I want to go over is an instance variable. So instance variables are variables that are shared by the object only. So let me show you an example. Now, I'm going to have a separate video dedicated to object-oriented programming, but just to explain what an instance variable is, we'll do a small example here. So let's say I have a class called hello. All right, so class hello. And let's say I have an empty constructor. Actually, you know what? Let's say it takes in x and y. Self.x is equal to x. Self.y is equal to y. All right, so these are going to be what's called an instance variable. So when the object is created for this class hello, we are going to call up on these variables. So let's see how that works. So let's say I have my object called hello, where I'm creating a new object with takes in 1 and 2. And let me import this. All right. So now if I do print hello.x, print hello.y. So these are instance variable tied to this object called hello. So when I run this, I should get 1 and 2. Let's create a new object. I'm going to copy this. Let's call it hello2. And maybe we can do 5 and 232. Let's run this. Oh, okay, this should be hello2. All right, there you go. So you can see what's going on. So each of these instance variables are tied to its own object. So this is an example of what an instance variable is. All right, so the next topic I want to go over is a Python memory model, and we want to see how Python stores these objects, these variables inside the memory. So Python is actually written in C language, at least the default CPython. Python is an interpreted programming language, and it compiles down to computer-readable instructions called bytecode, very similar to Java. There's also Jython, which gets compiled to Java bytecode, and these bytecodes are interpreted by the virtual machine, which allows us to run Python code. So we can even see, which version of Python we're using by printing it out from the platform package. So if you do print platform dot, I believe there is platform implementation, Python implementation. So we can see which Python we're using. So here we're using CPython. So CPython is a default implementation of Python, which you download from the Python website. So when we're running Python application, the data is being stored on a physical device. It could be RAM or hard drive. The operating system directly interacts with this physical memory, and there are a couple of levels of abstractions from this physical hardware to Python. And the way that works is the operating system takes this physical memory and creates a virtual memory layer, which Python uses. And this creates a separate process which is used by Python only within this virtual memory block. Now, Python uses this memory manager, which uses an object allocator to allocate memory for Python object inside this private heap. It also utilizes this raw memory allocator to check if there is enough space inside this private heap by interacting with the OS memory manager. Variable, function, and object references are stored inside the stack. The memory manager also automatically cleans up the memory of objects that no longer have any references, and this process is called garbage collection. All of this process is automated in Python by the Python memory manager, and we don't need to worry about managing memory ourselves. In fact, in Python, we have no control over how memory is managed. So this memory manager is pretty complex, and it's very smart and powerful in properly allocating memory and checking what type of objects we're storing. For example, integer objects are managed differently than string objects in order to give us best performance and best use of space or storage. All right, let's do a small example. Okay, when we run this program, a heap is created by the Python memory manager, a private heap, and a stack. Okay, stack. And then we have this first method called main. So main gets placed on top of the stack. So we have our main method here, main. Now, everything in Python is an object. So when we create these variables A, B, and C, these will be created inside the stack. So A, B, and C. And the objects 10 and 50 will be inside the heap. So we have 10 and 50. Now Python is going to optimize this automatically. A will be pointing to 10, and B and C will both point to 50. So this is a way how Python optimizes the memory allocation. It doesn't create a new object for us. These two variables will point automatically to to 50. We can even check it out. So we can print out the memory location of variable B and C. So let's do B. And let's do C. And we'll just do A as well, just to showcase the difference. So if we run this, A is pointing at a different location in memory. Now you can see B and C both are pointing to the exact same location in the memory, shown here. So next, we're calling the add function. Add will be placed on top of the stack with its parameters A1 and B1. We're storing the result in the new variable sumRes. So sumRes will be created inside this stack frame, sumRes. And the value or the object of that will be stored inside the heap. So it's going to be 10 plus 50, 10 plus 50, which is 60. And sumRes will be pointing to this. Next, we return back to the caller, which was here. And now res will be placed inside the main method. Res will point to 60. And now stack is a last in, first out data structure. So what's going to happen is this whole thing will be popped out of the stack. So this will be gone. This reference will be deleted from here. All right, so this reference will be deleted from here. And res will be pointing to 60. So on the next line, we're creating a new hello object from the class hello. So the variable will be here. And the object will be created inside the heap. Hello with its values 1 and 2. All right, so with its value 1 and 2. And this hello will be pointing to this object here. So after we print out these objects with its value, main method will be finished, and then main will be popped out of the stack next. And then there's not going to be any references to these objects. All right, there won't be any references. Then garbage collection will kick in, and it will destroy all of these objects for us. So this was a brief overview of the Python memory model. And the next and final topic I want to briefly go into is the difference between dynamically typed versus statically typed languages. So Python is a dynamically typed language, and in simplest terms, it means we don't have to define a type like we do in languages like C or C++ or Java, which are strongly typed languages, sometimes also called statically typed. Everything in Python is an object. So Python name, this name, is just a label, and the value is an object. So for example, when we do C is equal to 50, we're not defining a type here at all. So what Python does is it creates a Py object in memory of 50, and the type becomes integer. And the name C here, it starts pointing to that object 50 in memory. So the benefit of being dynamically typed is first, it's faster to code. And we as programmers don't need to specify the types. And this makes Python one of the go-to languages for quick prototyping and IDEA. The negative of being dynamically typed is that first, it can be slower. Types are checked during runtime, meaning during execution of the code. For example, if I have, let's say, a variable res where I'm performing addition operations on A and B, what Python will first do is it's going to check the type of these variables A and B. It then has to check whether they support being added, where we can perform an addition. It has to check that. It then has to extract this addition operation, this addition function, and see if you can even add them. Because sometimes due to operator overloading, objects can have custom definition of this addition operation. It then has to extract the values of A and B and then perform the addition operation on it. And then it has to create a new variable res inside of memory and store the result there. So it has to do this every single time while the code is running. Another negative can be that it can be a lot more error prone. As these types are not checked during compile time, they're checked during runtime, it can lead to lots of error during execution of the code. For example, if a variable, let's say E, which is a string, hello, let's say, and I have a new variable res2 where I'm adding C plus E. Now, if this was a statically typed language like Java, it would already give us an error. We cannot add C and E together because E is of type, C is of type integer and E is of type string. This will only check this during runtime. So for example, if I run this, I'm going to get a runtime error where it says, you cannot perform this addition operation on integer and string. Hopefully you guys got a better understanding of variables in Python and how Python stores these variables or objects in memory and how the memory model of Python works, specifically CPython. I've also done a very similar video like this for Java as well. So if you guys are interested in learning about Java and the Java memory model, please do check that out. I will have lots of other videos on my channel going from basic to advanced, and the next video will be on conditional statement, both in Python and Java.